All right, we're in chapter 7. And this is digital circuits. And we get to talk about math. No, we don't even get to talk about math. We get to talk about arithmetic. That's even better, arithmetic. So 1 plus 1. That's not a 1. Anyway, 1 plus 3 is 2. No, 1 plus 2 is 3. There you go. So we're talking about math. How are we going to do it? And we're going to have to do it with binary numbers because all my electronic circuits, all they know is ones and zeros. They're pretty stupid. That's all they know. So that means that's what we're going to have to do. All right, so what is it that we have? We have a 1, and we add it to a 1, and what are we going to get?
1, 0.
We're going to get a 0, and we're going to get a carry. So we get a carry, that's 1. And the number is going to be 1, 0. That's absolutely right. So now we look at what is that sum look like. So we have the sum of, and that's A and B. So that's going to be A exclusive or B is going to give, if this is A and that's B, and they're both 1, I get a 0. If they're both 0, I get a 0. If one is 0 and the other one is 1, I get a 1. And so that's my summation. And then when do I get the carry? How do I get the carry? Carry is AB. They both have to be 1 to get a carry. So I got a truth table. And I got A, B, I got the sum, and I got the carry. 0, 0, I got a 0 on the sum, I got a 0 on the carry. 0, 1, got a 1 on the sum, I got a 0 on the carry. 1, 0, 1 on the sum, 0 on the carry. 1, 1, I get a 0 on the sum and a 1 on the carry. And we call this thing a half adder. Why would it be a half adder? H-A-L-F. Half adder. Yeah. Well, we call it a half adder because there's no carry in. So now we'll have to consider it again. Then we're going to have to consider, well, what happens if I have a carry in? So I got A, B, and I got a carry in. What is my sum going to be? And what is my carry out going to be? So look at that truth table. 0, 0, 1. Sum is 1, carry out is 0. 0, 1, 0. Sum is 1, carry out is 0. 1, no, I don't want a 1 there, do I? 0, 1, 1. The sum is 0, the carry out is 1. 1, 0, 0. The sum is 1, the carry out is 0. 1, 0, 1. The sum is 0, the carry out is 1. 1, 1, 0. Sum is 0, carry out is 1. 1, 1, 1. Sum is 1, carry out is 1. So now I have a truth table where I'm adding, what happened? All right. That was me. Where I'm adding two numbers, A and B, they're just binary numbers, and I'm getting a carry out. Now I'm going to ask myself, what is the right answer for the carry out, and what is the right answer for the summation? So that's the issue. So what logical stuff is going on there anyway? Wish I remembered. Wouldn't have to go looking for it. I'm going to have to go looking for it. Well, That's what. Okay. Well, we'll just continue. We'll get to what the electronics looks like later, I suppose. All right. So let's add some numbers. 1, 2, 3. Doesn't look like 1, 2, 3. 5, 7, 4. All right. So we're going to add those numbers together. We'll call it a 9 because it looks like a 9. 9 plus 3 is 2, 1 to carry. 7, 3, and 1 is 1, 1 to carry. 5, 6, 7. Okay, so now I'm going to do it with binary numbers. 0, 1, 1, 0, 1. 1, 0, 0, 0, 1. 0, 0, 1, 1, 0. Okay. 1 and 1 is 0 with a 1 to carry. 1 and 1 is 0 with 1 to carry. 1, 1 and 1 is 1, 1 to carry. 1 and 1 is 0, 1 to carry. 1 and 1 is 0, 1 to carry. Okay. That's it. I added. I'm in binary. I'm only allowed to have 1s and 0s. 1 and 1 is 0, 1 to carry. 1 and 1 is 0, 1 to carry. 1, 1 and 1 is 1, 1 to carry. 1 and 1 is 0, 1 to carry. 0, 1 to carry. That's the last carry.
The binary is then just like 7, 12 or
And say again? What's the issue? This is 8, 12, 13. That's 16, 17. This is 6. So I got 6, 1 to carry, 36. This is the 32 plus a 4 is 36.
That's actually writing this down. Do you normally box in the last number if it's a carry?
You normally indicate that it's a carry. It's not really part of the number. It's something different. Yeah. Yeah.
Numbers on the right have nothing to do with numbers on the left. You're just adding binary.
I'm just adding binary.
Adding
Right?
regular.
Yeah, but I'm adding binary the way I'd add binary. The question was, why do I make the carry different? That was the question. And why can't I just put it there? Well, maybe this chapter, maybe the next chapter, in some chapter soon, we come to how do we deal with negative numbers? And the way we deal with negative numbers is use something called TwosComplement. And in TwosComplement, the most significant bit is weighted negatively. So if I have a number 1, 0, 1, 0 in 2's complement, then this guy here means -8. That guy there means 2, and this number is a -6. Okay, so when I'm adding things together and I have 5 bits that I'm adding together, I can't just add a 7th bit and call that okay. This might be a 2's complement number where that 7th bit is weighted negatively. And that's why the carry is treated differently than just putting it at the other end. So when I do decimal math, I add a 197 to 5,936. It doesn't matter. I can go to the 100,000 spot or the 10,000 spot. In binary numbers, I may not be able to do that. I may be restricted in my ability to do that.
So when you circle the binary digit, that makes it negative?
No.
No.
Being in 2's complement math makes the most significant bit negative. So if I have 8-bit, I'm using 8-bit math, and I want to know what negative 4 is. In 8, I write down 4. 0, 0, 0, 0, 0, 0, 0, 0,
1, 0,
1, 0, 0. So that is 4 in an 8-bit math system. In order to find negative 4, what I'm going to do is I'm going to change all the 1s to 0 and all the 0s to 1. 1, 1, 1, 1, 1, 0, 1, 1. To make it a 2's complement number, I'm going to add 1 to that. 0, 1 to carry. 0, 1 to carry. 1, 1, 1, 1, 1, 1. That's negative 4 in 2's complement. Okay, because this is weighted negatively. So I look at this, and that's a unit, 2, 4, 8, 16, 32, 64, 128. Unit 2, 4, 8, 16, 32, 64, 128. So minus 128 plus 64 plus 32 plus 16 plus 8 plus 4 gives you what? Minus 4.
24.
Gives you minus 4. Now if I add 4 and minus 4, what should my answer be?
0.
Okay, so I'm going to add 4 and minus 4. 1, 1, 1, 1, 1, 1, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0. All right, I'm going to add those. 0, 0, 0, 0, 0, 0, 1, 1, 0, carry the 1. 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 1, 1, 0, 0, carry the 1. Notice that that carry is outside of the 8-bit math system. It is a carry. The number I have is 0. I added 4 and negative 4, and I got a 0.
So if there's a 9th digit, that is a negative number.
No, the 9th digit, there isn't a 9th digit. You only have 8 bits of digits. Only have 8 of them.
That's 9.
The most significant.
But that's a carry. The most significant guy is the 8th guy. That's a carry bit. That's not a numeric bit. It's a carry. And when you're adding in 2's complement, the carry goes away. You drop it. That's 0. Plus 4 minus 4. That's what your calculator is doing, by the way. When your calculator adds, subtracts, multiplies, divides, it does it in 2's complement math in binary numbers and displays it to you in what you see in decimal seamlessly. Okay, I knew you wanted to know that, and we will do it again. All right, so now we're going to multiply. 12 doesn't look like a 12 times 25. Okay, so 5 times 2, 0, 1 to carry. 5 times 1 is 5, 1 is 6. 2 times 2 is 4. 2 times 1 is 2. I add 0, 0, 3. 300. All right, now I'm going to do it again. 12, 1, 1, 0, 0. 25, 16, and 8 is 24, 25. 1 times 0 is 0, 1 times 0 is 0, 1 times 1 is 1, 1 times 1 is 1. 0 times 0 is 0, 0 times 0 is 0, 1 times 0 is 0, 1 times 0, let's see.
Four zeros.
I gotta do another 0, 0, 0, 0, one more 0. 1 times 1 is
You got one
1.
more zero.
1 times 1 is 1. 1, 2, 3, 4. I think that's enough. 1, 2, 3. No, 1, 2, 3, 4. Yeah. All right, next guy. I got one more to multiply here. 0, 0, 1, 1. I add 0, 0, 1, 1, 0, 1, 0, 1 to carry, 0, 1 to carry. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's got to be too many, doesn't it?
Yeah, what's the middle row? I say 6.
You want me to do it over again? I'll do it over again. I don't think it's right. That's what I'm going to do it over. Okay, so I got 12. 1, 1, 0, 0. I got 25. There's 16. There's 8 for 24. And there's 25. 1, 1, 1, 0, 0.
No, which one do you multiply here then?
1 times 0 is 0. 1 times 0 is 0. Just like I did here. 5 times 2, 0, carry the 1. 1 times 1 is 1. 1 times 1 is 1. 0 times 0 is 0. 0 times 0 is 0. The whole roll is 0. 1 times 0, 0, 0, 1, 1. 1.
Where's the, how are you getting
1 times
6?
1, 1 times 1.
Well, you skipping the 2 zeros. Wow.
What 2 zeros?
Well, 1 times
Hi.
1, 0, 0 is 1, 1, 0, 0. 0 times 1, 1, 0, 0 is
1,
0, 0, 0.
0, no, 0, 0, 1, 1.
Yeah.
0 times 0 is 0. 0 times 0 is 0. 0 times 1 is 0. 0 times 1 is 0. Is that better?
Yeah, there's another set of those 4 again.
Now, 0 times 0 is 0. 0 times 0 is 0. 0 times 1 is 0. 0 times 1 is 0. 1 times 0 is 0. 1 times 0 is 0. 1 times 1 is 1. 1 times 1 is 1. 1 times 0 is 0. 1 times 0 is 0. 1 times 1 is 1. 1 times 1 is 1. 0, 0, 1, 1, 0, 1, 0, 1 to carry, 0, 1 to carry, 1.
Then we can put a box around that.
No. No, because I'm not doing 2's complement math. I'm trying to get to 300, and I'm not going to get to 300 if I'm going to do that. All right, so this is 256, 128, 64, 32, 8, and 4.
260 plus 40, 300.
I don't see it myself. Oh, yes, I do see it myself. All right. I was calling that as 84. Okay, so there's 10 and there's another 10. So that's 0, 2 to carry. There's 5 and 5 for 0, 1 to carry, 300. Yes, we did it. All right, so I can do binary multiplication. Now I don't want to do binary multiplication, but I can. I can also do binary division. So I got 5, and I'm going to go into 136. Okay, so I go in 2 times, and I get 36. I go in 7 times, I get 35, and I have a remainder of 1. Okay, so I've got 5, 1, 0, 1. I'm going to divide that into 136. So there's 128. That means I have 8 left over. 64, 32, 16, 8, no 4s, no 2s, no 1s. Huh?
8 plus 1632, 64, 123.
Okay, so does 101 go into 100? No, it doesn't. But it does go into 1,000. So I'll put a 1 there. 101. I subtract. I have to borrow. So 1 from 1 is 0. 0 from 1 is 1. 1 from 1 is 0. Okay. It goes in there one time. 1, 1, 0, 1. Darn. Remainder 0. 1 to 4, 8. 16 and 8 is 24. How come I get 24?
I think we need more.
1 minus 0 is 1. 0 minus 1 is 1 minus 1 is 0. That's going to be a 1 minus 0. 1 minus 1 is 0. Looks right.
No, it's not right. Came up with 24. It's wrong.
Well, I know in regular math, like the remainder of 1 is actually like 1 over 5.
All right, so I'm gonna borrow.
0, 0, 0. You have to
All right, so 1, 0, 0, 0, 1, 0, 1. Okay, I'm gonna borrow from there. I have a 1, 0 here. I'm going to borrow from here. I have a 1, 0 here. And a 1 there. No. Okay, I have 8. I'm subtracting 5. I'm supposed to get 3, right? Okay, I got it. I'm borrowing. This guy is a 1, 0. That guy's a 1. That guy's a 1. Okay. 1 from 1, 0 is a 1. 1. 1 from 1 is 0. That's what I did. Okay, that's this number here.
What is the subtraction?
I'm borrowing. So just like I didn't have to borrow there, but I'm borrowing the 1 and I'm getting a 1, 0 there. I'm borrowing 1 from the 1, 0. I'm getting a 1, 0 here, but I got a 1 back there. I'm borrowing from the 1, 0. I got a 1, 0 here, but I got a 1 back there. So I got a 1, 0, 1, and a 1. What's a 1, 0, a 1, 0, and a 1, 0, 0? What is that? 0, 0, 0, 1, which is exactly what I had there. Say, where was I? 0, 1, 1, 1, 0, 0, 0. All right, back to what we're doing. I go in there one time. 1 time, 1, 0, 1. Right? I subtract, I get a 1, 0, 0, 0, 0. Okay? I go in into there 0 times. I go into there 1 time. 1, 0, 1. I subtract 0, 0, 1, 1. No.
I mean, one place over to the right.
No.
0, 1.
Come back to here. I can't go into 100. I put a 0 there. I can go into 1,000. I put a 1 there. 1, 0, 1. All right, now I'm going to subtract 1, 1, 0, bring down to 0. I go in there one time, 1, 0, 1, remainder 1. I'm supposed to have a 27 up there. 16, 24, 25, 26, 27. Boom, I did it. All right. Aren't you glad your calculator does it for you? Now we're in 7-2, and what's the topic in 7-2? 2's complement representation. Yeah, I knew we were going to have to deal with 2's complement representation. All right, so in 2's complement, oh, there's also a 1's complement. We'll talk about 1's complement. 1's complement. So if I have 0, 0, 0, 0, 0, in 1's complement, it's 1, 1, 1, 1, 1. All I do is change all the zeros to 1 and all the 1's to zeros. In 2's complement, I change all the zeros to 1, all the 1's to 0, and add 1. So that's what I did. So in 2's complement, the most significant bit is negative. If I could have 8 bits, I could have 16 bits, I could have 32 bits, I could have 64 bits in my number representation. It doesn't matter how many I have, but the most significant one is going to be negative. So if I have 16 bits, and I look at 2 to the 16th, what's my number? Why isn't my calculator on? 2 raised to the 16th. 65,536. Also known as 64K. Right? So when we talk about 64K, or we talk about 1 meg, or we talk about 1 gig, we're talking about 2 raised to some exponent. We're talking about 65,536, but we're calling it 64K. And in your microprocessor class, you should have gone over that sometime, or we'll go over that sometime. So 1K is how much? 2 to the 10th, which is how much? 1028, I think. Is it 1028? 2 raised to the 10th. 224. I knew that. But we call it 1K. But it's really 1024. Okay, so if I look at that number, 65536, in 2's complement math, I could have a 1, 0, 0, 0, 16-bit, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, and that would be minus minus 65536. Or I could have 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and I'd have a positive number, 6, 5, 5, 3, 5. So I can only go from 65,535 to minus 65,536. Those are the furthest my range can go in 16-bit math. If I want a decimal place and I want to have fractions, then I'm going to have more than 16 bits so I can have more room for them. But if that's as big as I can go. So if I'm counting beer kegs, I'm in a manufacturing setting, my microprocessor is sitting there, my PLC is sitting there counting beer kegs, and I get to 65,535 beer kegs, and I count one more, the number I have is minus 65,536 beer kegs. And the processor is in fault because it just said, you hoser, you shouldn't have allowed that to happen. Okay. So if you're, when you add and it's called an overflow, you get an overflow and the processor goes into fault. Our PLCs only work with 16-bit math. That's all they're going to do. Okay, 2's complement representation. So we want to go from, I want to go from something, I don't know what I want to do. 273, I want to go, well, I want to know what minus 273 is. And I'm going to use 16 bits to do it. Okay, so the first thing I'm going to do is find 273. And so units, 2's, 4's, 8's, 16's, 32's, 64's, 128's, 256's. So I needed 256. 256.
17.
I have 17. So I don't need one of those, none of those, none of those. 1, 0, 0, 0, 1. And then I need 16 bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, now I have 16 bits. Now I'm going to change all the zeros to ones and all the ones to zeros. Then I'm going to add 1.
What's the significance of adding the 1 line for? Why do you do that?
That's going to be an interesting answer. You're not going to like it.
Just because it's one of the rules of the.
It is one of the rules, yes. So now the issue is, why would I have to do that? Why would I have to add 1? Yeah. And I'm sorry, I'm a math major. I can't answer that question easily. Yeah, like I say, you're not going to like the answer. So we're not going to confuse you with the answer. I'm going to tell you have to add 1.
Like something that transferred over or something.
Now, if I decided I'm going to do the same thing over again, 273, and I want it in 10-bit math. All right, is that all right? Take my calculator. Nothing up my sleeve. Take my calculator, turn it on. Minus 273. Minus 273. Second function, base, convert to binary, boom. And it says it's 1 0 1 1 1 0 1 1 1 1. My calculator just told me it was that. What if I wanted okay. What if I wanted 16-bit math? And I have the 10-bit answer. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. Now I have the 16-bit answer. The TI-85s, 87s, 86s, 89s will do 16-bit 2's complement math. This guy will not.
So you just have to add the extra 1.
You're going to have to add the extra ones. And as you do that, yeah, that's what you have to do. All right, likewise, let's say I wanted minus 37. Okay, but I want it as 8-bit math, 8-bit. But my calculator is going to give me the 10-bit answer. Minus 8, second function, change the base to binary. And my calculator says the answer is 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's what my calculator said. Now, if that's 10 of them, what would be the 8-bit answer? There's 10 there. So the 8-bit answer would be 1, 1, 1, 1, 1, 0, 0, 0. This guy is minus 256 plus a 128 plus a 64 plus a 32 plus an 8. How can that be negative? Oh, I know why. This is minus 8. I put a minus 8 in my calculator, not a minus 37 like I wanted to. So that's going to be minus 8, right? Minus 256 plus 128 plus 64 plus 32 plus 16. I left the 16 out, plus 8. Yep, minus 8. I left the 16 out right there, 16. Okay. So now we're going to do 2's complement arithmetic. Okay, we'll do that. Okay, I want 37 minus 10. Okay, and better be 27 when I get done, right? Okay, so that's but what we're going to do is we're going to change the 37 to a binary number. 37, change it to a binary number. 1, 0, 0, 1, 0, 1. And I'm going to use 8-bit math. 1, 2, 3, 4, 5, 6, 7, 8. And then I want minus 10 as a binary number. Well, we'll go with 10. What's 10? 0, 0, 0, 0, 1, 0, 1, 0 is 10, right? And then we're gonna complement it. 1, 1, 1, 1, 0, 1, 0, 1. And then we're gonna add 1 to it. 0, 1 to carry, 1, 0, 1, 1, 1, 1. Okay, so I'm going to take 1, 1, 1, 1, 0, 1, 1, 0. Okay, so now I've got 37 and I got minus 10, and I'm going to add them. 1 and 0 is 1, 0 and 1 is 1, 1 and 1, 0, 1 to carry, 1, 1, 0, 1 to carry, 0, 1 to carry, 0, 1 to carry, and we throw it away.
So you just made it minus negative 10 and then?
No, I'm adding a negative 10, right. Yeah. This calculator doesn't subtract. This calculator only adds. It adds negative numbers.
What prevents me from thinking that negative 10 isn't 2 plus 4 plus 16 plus 32 plus 64 plus 128, which is all positives? I mean,
because I'm in,
that's a negative number?
because I'm in 2's complement math, and my calculator knows I am. The calculator is not going to be confused.
Well, when I see that number, I'm not thinking negative, I'm thinking...
Well, quit thinking and jump on the program. And yeah, because we're in this section of the book doing 2's complement math, this is a negative number. Anyway, back to what this number is. What's this number? 16, 8, and 3. 16, 8, and 3. Can't be. Oh yeah, that is 27. Check. But notice that I threw the carry away. I'm doing 2's complement math. The carry gets thrown away. Okay, we'll do it another time. Do something else. Let's say I got minus 10, minus 10. And because it's a pain in the rear end, we're only going to use 5 bits. Only going to use 5 bits. All right, so 10 would be 0, 1, 0, 1, 0. I complement it 1, 0, 1, 0, 1. I add 1, and that's a 0, 1, 1, 0, 1. Okay, so minus 10, the minus 10 representation in 5-bit binary is 1, 0, 1, 1, 0. And I'm going to add 1, 0, 1, 1, 0 to it. I'm going to add minus 10 and minus 10. 0, 1, 1 to 0, 0. 1 to carry. 1, 1 to carry. 1, 0. And I throw away the 1. How disgusting. How did that happen? Zero, 0, 1 to carry, 1, 1 to carry, 0, 1. That's an 8. That's a 12. How did I get 12? I was supposed to be getting minus 20. Well, if I would have written, if I,
22's complement.
16.
boom, 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 1 to carry, boom. Okay, I'm going to do it again. 1, 0, 1, 1, 0. 1, 0, 1, 1, 0. So I'm adding minus 10 to minus 10. 0, 0, 1 to carry, 1, 1 to carry, 1, 0, 0, 1, 1, 0, and I throw away the carry. Boom, throw it away. And I get bummer.
4 8's 12.
You did it right.
Yeah, but now this carry guy has to be this. Yeah, I might not be able to do it in 5. Yeah.
If it was 8, then that would.
All right. You're right. Forget about 5-bit. Doing 8-bit math, we want minus 10. Okay, 0, 0, 0, 0, 1, 0, 1, 0. We complement it. We add 1. 1, 1, 1, 1, 0, 1, 1, 0. And then we're going to add it on itself. 1, 1, 1, 1, 0, 1, 1, 0. 0,
But isn't it,
0.
from the start, you would have done it the other way, we would have tried 0, 0, because the 1s would have carried over. From right there.
0,
0,
1.
1 carried over, so that would have been 0 there.
No, because I complemented this. I'm adding those two. 0, that's a 1. That's a 1, that's a 0, that's a 1, that's a 1. Yeah. I'm not adding the guys on top, no,
Not adding those.
no. 0, 1 to carry, 1, 1. 0, 1 to carry, 1, 1 to carry, 1, 1 to carry, 1, 1 is out. Okay. This is minus 256 plus 128 plus 64. Oh, we're missing something. 120. No 32. A 16. But that's an 8. Units. 1, 2, 3. Units. 2, 4, 8, 16, 32, 64. Okay, we start at minus 128. Minus 128, 64, 32, 8, and 4. And we're supposed to get a minus 20.
68 plus 40 is 108.
Yeah, minus 20.
64, 132, and 8 is 124. 4 is
Yep, minus 20.
32 and 8 is 40. That's
Minus
108.
20.
128 minus, or negative 128.
Yep. All right, there we go. We did it. All right.
So the thing is, like, if you have more than, if you have like a 2-bit number, then you have to do 16 bits.
Yeah, you go to 16 bits or 64 bits or 128 bits. You know. All right. So one more time. We're going to do hexadecimal math. All right. So I'm going to add, what are we going to add? A, B, C to F, D, 1. Now, how are we going to do that? We're going to take our calculator, and we're going to put in the numbers, right? So we're going to go A, B, C, second function, base,
10, 11.
type, hexadecimal, plus second function F, second function D, 1, second function base, type, hexadecimal, enter. And then we're going to get a number. Yeah, okay. We're going to get 6797. Is that a hexadecimal number or is that a decimal number? So,
If you hit enter, you gotta put it in decimal.
yeah. So I'm probably going to have to go second function base, convert to hexadecimal. Okay, so it's probably A1A 8D. Okay, so on the side, A, B, C, F, D, 1. Okay, C, which is 12, and 1 gives us 13, which is a D. Okay, I didn't carry anything. B, which is an 11, plus D, which is a 13, gives me a 24. 24. So that's a carry of 1 of 16. 24 minus 16 is 8. How do I know that? Because I'm looking at right here. I've got an A, an F, which is 15, an A, which is 10, and a 1. 15, 25, 26. I take away 16, leaving me 10 left. I get an A. Yeah, I think we're better off just doing it on our calculator. Yeah, probably so. Do we have to subtract these guys too? Yeah, we gotta subtract them. And we gotta,
797 in decimal form.
How
Yeah.
would you do it in your calculator again?
One step at a time. Okay, so, okay, here we go. Second function, A. Second function, B. Second function, C.
Yeah, you see the letters.
Plus.
Uh-huh.
Yeah, the letters are above the numbers.
Don't you have to identify a second hexadecimal first?
No. Let's see, did I do that? Yes. Then I have to go and tell second function C, and then I have to do a second function base and type hexadecimal H
That's what I did.
plus second function F, second function D, 1, type, well, second function base, type, H, hexadecimal, enter. And because the calculator is stuck in its ways, it's going to give you a decimal number. So now you have to go second function base, change to hex. That's an delete out thingy. And then I'll give you the number in hexadecimal.
188B, 1 alpha 8 delta.
Yeah. 1 alpha 8 delta with an H. All right. Well, this leaves a lot of room on the next test, right? To have a chart exactly like the chart you had on the first test, wanting you to change things back and forth again. You know, lots of room there. Okay, well, we'll call it a day.
Friggin' spaghetti brains now.